Hi everyone, welcome to the fourth webinar from Movimento in partnership with HCL. Today's webinar is about saving lives using artificial intelligence and context-based automotive OTA software update. It's a mouthful of words, but basically it's about how does automotive save lives when you have a contextual decision making in terms of what updates and when do you do those updates and how does it help save lives in different scenarios. So the agenda for today's talk is going to be, first we're going to do the recap of the webinars. We had 3 webinars before which really teed up to this moment. So we're just going to go over those and remind everybody of all the 3 webinars and the key takeaways from that. Then we're going to look into the software-defined car stack in the vehicle, inside the vehicle, and then we need to look at what is outside the vehicle, because in order to have a complete system, it's both off vehicle and on vehicle architecture. Then we're going to look at the environment and the impacts of the vehicles and the pollutions and how and the different scenarios that plays in there. Then we're going to introduce the concept of conceptual decision making, and this is about location and understanding the surrounding and making the right decisions about what kind of updates, what kind of software profile, what kind of data exchange needs to happen in order to make the right decision at that moment. And then we're going to have an amazing demo, and this demo will articulate the value proposition that we bring to the marketplace, and then we'll end up with the key takeaways followed by Q&A. So with no further ado, let me just jump directly into the content. So the first webinar, if you remember, it was about monetizing the software-defined car with secure OTA application and content update. And what is it about is that this was the very first one, and we introduced the concept of software-defined evolution of automotive. So we have seen automotive evolving from hardware-enabled to software-enabled to a software-defined. And this is basically as the importance of the software became more and more into the electronics and more as well as reconfiguring or updating those software. So you can imagine a similar journey that you have seen with your mobile phone. We had featured phone, then we had a lot of application on those featured phone. We could do a couple of things, then truly we went into a smartphone. And this is kind of the similar evolution that is happening in the automotive industry. The second one we talked about is automotive OEMs, manufacturers, care about. So as the software complexity is increasing, the threat of the cybersecurity is increasing, managing of those software is a great challenge throughout its life cycle, as well as things as how do they make revenue once the car is sold, how can they accelerate the development of the car when there is a lot of software involved, millions, tens and hundreds of millions of lines of codes are coming in there. These sort of things are at the top of their mind. Obviously, this is a new area for the OEM to manage the software life cycle and everything that comes with hyper connectivity. So this is we talked about it, and we also talked about how to address those. Then we looked into what is it required in this new era for the automotive automotive manufacturer. And we introduced a concept of marketplace with open innovation, embracing the open innovation. And this requires 3 things. It requires a software-defined car combined with a software-defined cloud platform and also the software-defined services. And these 3 together creates what is called a software-defined marketplace, which means you can now enable open innovation and embrace your partners and ecosystems to develop with you, and thus bringing to a new business model called co-innovation, co-marketing, co-revenue generation, and co-funding. If you think about it, it's all a co-X model. And that's the only way to stay current and be agile and very fast and provide innovative services by harnessing the power of the individual software vendors, your partners and others onto your platform, and then also sharing the revenue, sharing the benefits together with these partners. This is what is required. Then we focused on data monetization. Data is the new oil, as people say, and you will see that contextual data is probably then the rocket fuel for it, because it's so much data. Overwhelm of the data can overwhelm your services and other things. So you need to be more contextual, have the location, have the intelligence, and make smart decisions. And we talked about data monetization for real-time, non-real-time, individual vehicle on a massive scale, and how to position them and what are the values. And we also looked into how not all data are equal. Some data loses value with time very quickly. Other data are quite valuable, like predictive maintenance and other things are very valuable well into weeks and months later. And finally, we talked about the value prop of software-defined car, and we came into this concept of that software-defined car allows to reduce the operational expenses for the automotive by 100x. And this is basically, as the software content in the car is increasing, the recall, majority of the recall and warranty related issues are becoming more software bug related issues. And if you can do those updates and all those things over the year, that avoids the vehicle going to a dealership and all the expenses that comes with it, leave alone the fact that it's a hassle of scheduling appointment and getting a loaner cars and all those kind of things. That's on the operation expenses, but also it provides an amazing opportunity to keep the car safe. So the value proposition around security and countermeasure of security and proactive security is very important, because as you know, cars are getting connected. About 250 million cars will be connected by 2020, and in the foreseeable future, every car will be connected. And finally, also, the software-defined car value proposition allows you to monetize after the car is sold, and that is kind of new for the existing car business model, where basically you sell the car and it's in the books. But in the new model, it allows you to create a monetization model by providing new value-added services well after the car is sold, and also it's the foundation for creating mobility as a service business model. So that was all about the webinar 1. Again, all these things are available on Movimento's website, so feel free to go and look into those. The second webinar, we focused on security, and the title was Protecting Autonomous Vehicle and Connected Services with Software-Defined Perimeter. And in that one, we talked about the cyber attack and the vectors. And we looked at the different vectors, whether it is about DNS spoofing, whether it was about lateral moving malware. We talked about denial of service attacks. All the different types of attacks we talked about that are out there, including ransom and hijacking of the vehicle. So we focused on the attack vectors, and from there we looked at what are the challenges of today's solution. And today's solution that is in the marketplace, very much of an enterprise-related security solution, whereas the industry has evolved, connected services have evolved, so we need a very much more of a dynamic type of security solution, and also to make sure that we have a concept that of what we call secured enclaves, which is basically segmenting vehicle into different parts, and each part having a separate security certificates and security access, so that you can be very prescriptive about who gets access to which part. And then if for whatever reason one part get compromised, then you don't have an unfettered access to go from that zone of the security profile to any other zone or throughout the vehicle. That sort of concept was very important. And we introduced that concept using a technology called software-defined perimeter, and this is a new paradigm in the security, which is a cloud-native security solution, and introduce a concept of a control channel. And this control channel architecture allows you to set up the token before your communication happens. So you could now think about having a out-of-band communication for control channel, whereas your data communication happens through a different ways. And this is a very, very interesting way of securing scalable solution both inside the vehicle but also in the cloud and the application and cloud behind cloud. So this is a very cloud native security solution. So I encourage you to take a deeper look at the software defined parameter. And finally, we talked about a secure solution requires a closed looped architecture, which means what's happening in the vehicle, you need to be able to have the data exchange, bring those data back into the cloud on a regular basis, analyze them in terms of vulnerability of the operating system or application, and then proactively go and update those applications. So it requires a closed loop architecture of where you are bringing data from the car, analyzing, and then you are doing an update back into the car with the fixes. So this is this was the second webinar. The third webinar that we talked about was about securing the software-defined car, now using artificial intelligence and over-the-air software update. Now we talked about in the second webinar about the security and how you can have a SDP security, but now take a step forward is what kind of architecture and how do you secure in a more proactive manner before something happens? How do we do that? Most of the security solutions that are out there are usually looking at anomalies or looking at signatures and trying to prevent it or protect it in as much as possible. We need a more of a different type of solution where basically the machine learning, the model by itself can predict and write the code by itself in order to defend. So we introduced this concept. And that basically broke down into 5 key elements. One is, how do you secure the automotive car? So we talked about a 5C concept, and this is about the 5 layers. If you think of a mega security layers, one is around the first C is the the chipset, which is the hardware in the car. So whether you have TPM or hardware secure module, HSM, and where you store the keys. So we talked about that chipset level security. Then we talked about the client. These are the software and the clients and applications that are running. So in the car. So we talked about the client security. That's the second C. And then once you have those 2 C, then we talked about the connectivity. The third C is the connectivity, and that connectivity has twofold. One is connectivity within the vehicle. That from one module to other module to a centralized architecture of a kind of a mini data center or fog computing where a lot of intelligence resides. That is, so you have to secure the connectivity from the components and from the parts to this mini data center, as I call it. And have mutual authentication and between those parts before communication happens. You need to encrypt those, but that same connectivity also applies from car to the cloud. So there are 2 types of connectivity: connectivity within the car, connectivity from the car to the cloud. So that is the third C. The fourth C we talked about is the cloud. Whether that cloud is in the cloud, securing the cloud infrastructure, but also securing the mini cloud in the car, which we call the fog or the edge computing. So securing that is also very important. So that is the fourth C. And the fifth C of the security model is the content itself. Securing the content and making sure the data integrity, the data security is intact, and you have the signature, digital signature of the content and is verified, is absolutely paramount and important. So these are the 5 C. So when you think about securing a car, you got to think about this 5 C model. Then from there, then we went into the 4 layers of security stack within the car. if you remember, we talked about how do you secure within that silicon that we talked about in the car, but how do you secure at the bottom the firmware that really interacts and makes the hardware reconfigurable. So the firmware security is very important. On top of that, we have the software security, which is running the ADAS, the infotainment, a lot of other software that is running over there on top layer. Above and beyond, we need to secure the AI aspect. A lot of AI is coming. You already see vehicles with level 2 automated driving capabilities now. You need to secure those kind of applications at the AI and the data level. And then on top of that, what you have is the user experience, and this is where you have in-vehicle experience, whether the driver distraction, the head-up display, the augmented reality in the vehicle, all those sort of things, that user interfaces, you need to also secure that experience as well. So those are the 4 layers of security. Requires a very different way of securing each one. From there, we went into a basic overview of artificial intelligence, and we talked about the 3 categories of AI. We talked about artificial narrow intelligence, and very simple artificial narrow intelligence where machine intelligence is greater or equal to human intelligence for a very specific task. And then we talked about artificial general intelligence, which means the machine intelligence is greater or equal to human for any task. And the third one we talked about is artificial super intelligence, where machine intelligence is much superior than the human intelligence. Today's focus and most of the things that you see out there in AI world, artificial intelligence world, is really around artificial narrow intelligence. It's about one specific task that the machine does greater or equal to the human. So for example, the robotics are out there. They do a very specific task, but they are very efficient in doing that. In that respect, self-driving car, autonomous car is also an artificial narrow intelligence, because it does one thing and one thing, hopefully it will do better than the human, which is to drive you safely from A to B or wherever you're going. So that's what about artificial narrow intelligence is. And then we demystified that the AI world into the categories of how artificial intelligence encompasses machine learning. Within machine learning, how do you have the neural networks, and how within the neural networks you have the deep learning, which is basically multi-layer of filters of analyzing, so that you can recognize an image much better. So the deep learning is much relevant towards the image recognition type of things, object image recognitions and so on, whereas the machine learning is more around predictive or descriptive models, so which basically deals with a lot of data. So in our context of the security, we use machine learning technology to create a model. So we have trained data, and we have some past security vulnerable situations that has been logged, and historical data. We create a trained model, and then we use the trained model to bring in the live streaming data, and thereby analyzing the security. And as more and more data comes through the system, and more decisions we make, the systems becomes better and better. And that's what we talked about, the AI part. We also talked about the advanced security concept, and advanced security concept was a concept around couple of things around how do you have dynamic security. It's quite interesting if you have noticed your security posture and how you access today, whether it is your laptops or your banking or whatever you do. You have username, password, two-factor authentication, or multi-factor authentication, doesn't matter. Once you are authenticated, you are never asked again who you are. And the concept of continuous authentication is a way of saying, let's look at the behavior of the person once they are authenticated. What are they doing? Are we seeing some behavior different than we expect? So this, and then we want to re-authenticate as well, and also continuously monitor their behavior around that. So this is the concept around advanced security concept, and that was laid out in the third webinar. And finally, we created a system with what I talked about, AI-based threat prediction and mitigation. That was how do you do proactive. How does your system proactively look at something using the machine learning and then writes the code onto the device, whether it's in the cloud or in the car back, so that it writes the code by itself. So and so you are not waiting for a security attack that is human related response. So machine can respond by itself by protecting itself, and this is where the train model comes into place, and then train model is allowed to write back the codes, and so it's morphing and changing in terms of securing the system. So that's what we talked about in the third webinar. So with that, this is absolutely a great journey that we had from webinar 1, 2, and 3, and and now in this webinar we're talking about saving lives. Now, if we apply what we have learned through all of those, and you will see that how we are applying in our products today, and how we see the future of AI playing a key role in saving lives for connected car, autonomous vehicle, and the role of the software and data exchange over the year. So if you look at this, we talked about this in-vehicle software-defined stack, and this is what I was talking about, is that you need to think about from bottom up, the firmware level, the firmware update, which allows you to reconfigure hardware. So the way you secure a firmware is very different than the layer on top, which is where you secure and update softwares, and which could be domain controller and gateways and operating systems and so on. And from there, you have to move on to another higher layer, which is around AI and cognitive systems, because we are more and more relying on AI. And so the level of security that you need to imply for AI protection, whether it's algorithm or 3D maps. Imagine your 3D maps or your location spoofing, or is compromised, or some other coordinates are given thinking that it is that way, and you are relying on this. So the way you secure AI has to be very, very different, and the way you approach, then you do the software. And then the top layer is the UI layer, or UX layer, user experience layer, and this is where you are interacting with the vehicle and your profile, your productivity, and all those kind of things. So this is a different type of application. This is what we see more in the application world, like you see on your smartphone. So you need to apps on your smartphone. So this is how you need to think about in-vehicle architecture if you were to develop a software-defined car. And once now that car zoomed into the little thing on the left, which is the car over there. But in order to secure the car, it doesn't start from the car, it starts from the back end all the way. The car is now a connected system, so it's connecting to some cloud, and behind that cloud there are many other clouds, many other partners, content provider, solution provider, parts suppliers. So you need to secure the supply chain all the way, but the gateway to the car is centralized, and you want to make sure that you have a very secure delivery mechanism of software and content, and you have a very secure data exchange mechanism to bring those data and analyze every time to time. And this is the concept of a closed loop end-to-end architecture that you need for a software-defined car, and which is basically the foundation for connected car towards autonomous car. The reason why we don't really talk about connected car and autonomous car is because those are a particular feature capability. Connected car, it has connectivity. Autonomous car, we will talk about level 1 autonomous car, level 2. Those are just a feature functional capability, but the underlying architecture is a software-defined car. And that's why we emphasize on software-defined car, which is the foundation on which you build from the connected car to a fully autonomous car, and this is the architecture that you need. And this is also very important for vehicles when they are driving around and they do not recognize an image. The streaming data, in this case streaming video, will be streamed back to the cloud, and you could imagine there could be some autonomous car operators responsible for certain area. They could look at that what's in a real time, what the car is seeing and not recognizing, and give certain command to the autonomous car through the over the air command to say override or do X, Y, or Z, so that the car can move on instead of sitting idle. So this is a very, very important architecture, and this is how we have built our platform and how we see the future evolving. Now let's look into this use case for contextual update. Now contextual update we'll talk about in three areas. That this is just the beginning. You can think about contextual information all the time, because it's all about you and your surrounding, and the data that gives you about that moment is very important. To contextualize is very important. But in this case, we're just going to talk from the environment perspective. If you look at industrial area, especially in Far East, you see a lot of industries coming up, very high level of pollutions, and companies are trying to locate to a newer area, but pollution keeps on growing because a lot of manufacturing, a lot of cars. So how can cars and automotive behave in a much friendly manner in those areas for citizens and for the health related issue? Natural disaster, we see every now and then, whether it is flood or hurricane or a fire, how your autonomous vehicle or your electric vehicle or connected electric vehicle is going to play a key role to get away from that space and to go to a safer area. So how does your car understand those contextual information from the data that is not residing within the car only, but also coming from outside? And how do you make those decisions and then be more of a helping hand for people to move from location A to B? Maybe even have a better information knowing that if everybody's going to go the same route, how can you better do a route planning optimization as well to save the citizens? So we have a great demo on that. So we'll show you shortly. And the third one is global warming. That goes without saying that there are a lot of pollution and we are trying to reduce the emission, and how can we play a key role, especially you have seen in many parts of Europe where city centers are they're pushing away from cars coming into the city center so that you can have a better air quality and better livelihood. So how can vehicles even play a key role in those urban areas as well? So what is contextual data? Just to make it clear, it's a combination of location, where you are, some external data that is nothing to do with the car data, it's external data, then the vehicle data, how you are doing. And if you use these three parameters together, location, external data, and the vehicle data, you end up with what is called a contextual data. And that is a very important as we start ciphering, and as we start data, and as we start creating more and more smart services, we need more of the contextual data rather than data or smart data. So here's an example of a contextual decision making. So we talked about data, but decision making requires some intelligence. So in the examples that we will be talking about, we have a vehicle, and the vehicle is connected to a Movimento cloud, and there is we have access to the vehicle location. We're getting external data from two other sources. In this case, one is airvisual.io, which is giving the pollution. The other is the ozone, which is the forecast.io. The two other information is giving about based on the location exactly what the pollution air quality is and the ozone layer ozone quality is there of that particular location, and then the vehicle data in terms of how much the vehicle is emitting pollution. Combine that with the AI in terms of decision making in a dynamic way, creates a contextual decision, and you could use that contextual decision for very many different various purposes, and you can use the location to geofence it into say these areas you want any car entering or exiting this area should have this kind of characteristics in terms of air pollution and speeds and so on. So that becomes a contextual decision, and in our case we implement those contextual decision through a firmware or which is firmware update, which could be a configuration update, a very small few changes in the configuration. So it could be a configuration update, or it could be a full firmware update for certain parts of the vehicle. It can also be a software update. So that's what this contextual decision is, and we're gonna show a demo right now in terms of a contextual based software update and firmware update capability for vehicles using the Movimento platform.
In today's demo, I'll be showcasing how to save lives using contextual firmware update. Before we dive in, I'll be utilizing or focusing on something known as AQI, which is Air Quality Index. This is a number used by various agencies to indicate how polluted the air is or how polluted the atmosphere currently is for various geographical regions. The AQI itself is demarcated into various levels as seen here, with 0 to 50 being good, 51 to 100 being moderate, 151 onwards being unhealthy, and 300 and above being hazardous. For this demo, I'll be using APIs provided by AirVisual. Here is a map where they have shown the live at present AQI levels in various geographical regions. And as you can see on the left over here, towards the west, United States is pretty much covered in green, which with few yellows and oranges strewn in, which means the AQI levels are really good and at a low level, healthy level. But towards the east, as you can see, we have lots of reds, oranges and yellows, indicating that the AQI levels are high, which means it's unhealthy and even hazardous. So for the example, let's take a scenario where we have a user who's traveling from a place with high or healthy levels of AQI to unhealthy levels of AQI, so to speak. Let's take two places in the United States itself. To start with, I see a red peeking out over there. That's Oakville, Washington. And let's take a place from California. I see a 4. That's really healthy. Fresno, California. So we have our user traveling from Fresno, California to Oakville, Washington. We hit on go, and what you're seeing here is a dashboard, and we have our car here with the user on its journey, who is moving really slow. Let's speed him up, speeding him up further to get him going. Okay, so over here on the top, what you're seeing is the overlay of the route that our user is taking. Over here is supposed to be the live version of the path he is on. It would be a little more detailed, but at the speed at which he is going, the maps is unable to keep up. And on the right side over here, we have images provided by Google Earth's API. And on the top over here, the region marked as the car dashboard, we can see the details of the user and where he's headed. So over here you can see the AQI is showing as 155 for the destination, that is Oakville in Washington. The current temperature is 13, we have the UV index, the humidity, the wind speed is missing. Sometimes the data is available, sometimes it's not. Over here we have the distance he is currently covered, or the total distance to be covered, the speed he is going at. We have sped him up really fast, so he covers the distance by the time we are done with this demo. We see the car he is driving, the latitude, longitude of the destination he is headed to, and also the firmware version he is currently got on his card. So in this particular scenario, since the user is headed from a place with healthy levels of AQI to a place where the AQI levels are bordering on unhealthy, what the OEMs can do is offer him a firmware upgrade to calibrate and reconfigure his car in such a way that the emissions produced by his car are on a lower level to help maintain or to help reduce the pollution provided by his car. Let's learn down. Now, as he's entering into Washington, if our user chooses to do so, he can check for a firmware, and it notes that the AQI levels are high, and if he wants to, he can click yes on upgrading the firmware, clicks on OK, the message comes updating the firmware, and as you can see from 3.0 we have a firmware upgrade. Now it's at 3.1. Now the user moves on towards his destination, which is in Oakville, Washington, knowing well that his car is not contributing towards the emissions or the pollution in the area. In such scenarios, the OEMs can have a suite or a library of various versions of firmware that recalibrates or reconfigures the vehicle for any set destination or maybe certain levels of AQI. Let's say you're headed to a place with hazardous levels 350 or 300 and above levels of AQI. Maybe the OEM has a firmware that would make a trade-off between the power and the fuel efficiency in such a way that your car is really fuel efficient but reduces the power for a small duration of time that you are in the vicinity with a higher AQI. What I'm trying to say is that you can, or the OEMs can, provide firmwares to certain geographical areas with a high granularity. That makes geofencing possible with various parameters in mind. All you have to do is take a certain number and decide what's the ratio of the fuel efficiency versus the power that you would like to maintain with the vehicle such that the emissions are low. Now, the user has reached his destination as well. We can pause this. Now let's take another scenario with, let's see, as we noted earlier, we have a really high unhealthy and hazardous levels of AQI in the Asia Pacific region. Let's take a demo from, or let's run a demo from that area. Let's see. I see a plan which indicates Faridabad, Haryana. Okay, let's go with 352 Agra. It's a well-known place, home of Taj Mahal. Let's have someone going from Gwalior to Agra. So this part of the demo goes to show that contextual firmware update is not geographically limited. We all know that cars are available all over the world, and from the last count we had the number of cars in India at 22.5 million. China is even higher. We have 172 million cars on the road right now in China, with 23.8 million cars registered in 2015 alone. We don't have the numbers for 2017 yet. So, as you can see, we are traveling from Gwalior to a place called Agra with an AQI level of 353, and our user is making his way over there. We see the temperature in the destination is 17. We have the latitude and the longitude of Agra over there. The current firmware version is again 3.0. Now, as the user about to cross the border over here, he can check for the firmware update to see if it's available, and he's crossing the border. Let's see, it's safe to do so, and we check for the firmware. It says the AQI levels are high and you can upgrade the firmware in the car. We click on OK. We get the updating firmware option. As you can see, the 3.0 is updated to 3.1, and the user is well on his way to his destination. Now, in the beginning of this demo, I had mentioned that I'll be showcasing on how to save lives using contextual firmware update. Now, as I've shown in here with utilizing AQI, the same use case can also be applied in situations where there's a life-threatening situation, like let's say a natural disaster has hit a place. Let's say there's a flooding in a coastal region, a wildfire. Let's take the wildfire of Napa, for example. That's a recent situation, and it's still fresh on our minds. There was a large-scale devastation caused by wildfire to property and life, loss of high number of life, and there was evacuation alerts set to residents of the area, and everyone was trying to get out of Napa and Sonoma area as soon as they could. So in such a scenario, as we all know, we just try to take our belongings, our loved ones, get into the car and get out of the place as soon as possible. And in doing so, we usually, or it's been seen that people get stuck on freeways as they're trying to evacuate, and it takes a long time for the evacuation to completely occur. In such a situation, OEMs could provide an update, a map update, saying that, hey, we see that you are in the such and such situation. Here's a map update for you to get to safety in the quickest and safest manner possible. And they can provide such various map updates to various groups of people, so that the group such that the citizens in that area are dispersed, and they have multiple routes to get out of the harm's way in a safe manner. The firmware update can also be provided, and it's not just gasoline cars. If you think about it, it can also be for electric vehicles, where let's say you have consciously bought a mileage limited car, like let's say your battery capacity lets you drive 250 miles per one complete charge. Maybe the OEM can provide you with a firmware update, removing a software limitation, or recalibrating and reconfiguring your vehicle such that your air conditioning or your infotainment system takes less power but provides more power to the motors to help you go the farther distance. And those are just a couple of the scenarios where contextual firmware update comes in real use, and I hope this demo has been helpful. Please do not hesitate to contact us with any questions you may have. Thank you.
Fantastic. So hope the demo was gave an idea of how the contextual in relation to the location, geolocation, and also in this case air quality index was used, or also spoken about extending the electric vehicle range or routing people in a most efficient way, so that not everybody is going exiting a area of calamity or on the same route. So it can be used in many different ways when you have the contextual data, and then add that to a artificial intelligence. You have now contextual decision making, and then ability to take that decision and crowdsource of all the other vehicles and understand what's happening, and then allow groups vehicles to make different decisions. Gives you a lot of flexibility and would end up saving a lot of lives. So with this, I want to go into the key takeaways of today's one. Is the SDC architecture. We talked about the 4-layer architecture. Remember, we talked about the user experience, the artificial intelligence, the software features, and the firmware that helps reconfigure the hardware. So you need to think in the vehicle around this 4-layer architecture when it comes to designing your software-defined car. In addition to securing a software-defined car, and to make sure that you have a communication of improvements and also ability to crowdsource from all the other vehicle and learn and make some intelligent decision and disseminate those knowledge back into the car, you need what is a closed loop architecture. So this requires over the year data exchange model from the car and back, and then back into the car from the cloud. And so this is what is very important in making smart mobility or providing smart mobility services. And so you need for an end-to-end architecture, you need that. Third, for connected services, you need to think about having secure enclaves. You need to segment out the car into different parts. Not everybody should have access to everything. So applications that are related to user experience should not be able to get into the AI aspect of it, or things that are related to AI should not be able to get into the firmware aspect of the hardware configuration. So you need to segment out, make segmentation of the car, bring the concept of the software-defined parameters to have precision access as well, and then tie back with the cloud for making more of the proactive security measures using machine learning algorithms. Third, the new business model. So as I said earlier, if data is the new oil, contextual data is the super rocket fuel. So you can imagine that a contextual decision making helps you to make more predictive and decisions, or proactive, I should say, proactive decisions, and also it helps you to monetize. The value of a data based on the contextual is much more relevant to you than afterwards. Just a simple example, if I were to give you, you are at a San Francisco downtown and you want to look for a parking. And at that moment is very important which parking spots are open, at what price, and what's in your neighborhood. What if that information was given to you 10 minutes after? That loses its value. So contextual location, the external data from the parking, your vehicle location, and making a decision is absolutely important. And in the demo we showed a lot of other examples how those contextual information helps save life, and the value of it is huge. Last but not least, the contextual decision itself. It's a location, external data, vehicle data, AI allows you to do that, and with that you can think about the geofencing, and the examples were shown around eco drive, around electric vehicle range extension, but you could also think about targeted ads as well. If you have an idea of the profile of the user, the location, and the surrounding stores around it, so you could be more targeted. You can provide more targeted ads, and this could generate a lot of money, which could offset a lot of the cost of the technology that goes into the vehicle as well. So these were kind of the key takeaways from today's webinars. With that, I want to get into the Q&A, and if I go into the Q&A, I see one question from Siddhar, and this is about once you upgrade the firmware. This is a question from Siddhar, and I'm repeating. Once you update the firmware, is that a permanent setting on the drive efficiency, or will the driver need to again reset when he moves from a higher air quality index to a lower air quality region? The question is, it's a settings that you can give user the option at this moment. Again, because it's not a law, so we don't want to mandate it. It's a setting that you can give to the user, and you can proactively prompt it, but the user get to make a decision, yes or no. But in certain cases you could also enforce it, like we are seeing in the mobile world. To take an analogy with your smartphone, we see Amber Alerts. It's not a choice that you have that you get an Amber Alert. It's how we decided as a society, and the regulation decided that we should give out Amber Alert. So you could tie this to the emergency. In that case, you could have both settings automated, but also there could be other settings that you could give the user the benefit, and you could prompt it on the screen, and the user get to decide. So that's the flexibility of the choice. So that's one question that was out there. If there are more questions, please feel free to do the live chat. So just to summarize of all the 4 webinars that we have had for the last few months, We talked about the monetizing of the software-defined car. We talked about protecting the autonomous car. We talked about securing the software-defined car with AI, and today we are discussing about saving the lives. All these webinars are available at movimentogroup.com/movimento-webinars. So go and see there, and if you have any questions, please send questions even after this event to webinars@movimentogroup.com. Thank you for attending to this session. Thank you.